We're on number 8, and we're going to drive left and right to solve for dy dx. Cosecant y squared, we're going to have to use the chain rule, and that says derive the outside. So derivative cosecant is negative cosecant of what's inside times cotangent of what's inside. And remember, when you're driving cosecant and secant, same thing happens. It's not cosecant cotangent of y squared. It's cosecant of y squared cotangent of y squared. Every year kids write cosecant cotangent y squared, and it doesn't make any sense. That's like writing square root y squared. It can't be square root of nothing. It has to be something in there. Same thing with this cosecant. You can't just be cosecant of nothing cotangent y squared. It has to be cosecant of y squared. So just keep that in mind for when you derive cosecant and secant. Anyway, we just derived cosecant. Now we got to derive the inside, which is y squared. So derivative of that is 2y dy dx. And that equals, now we got to derive the right hand side. Secant, we derive the secant part. That's secant xy, tangent xy, times the derivative of what's inside of that, which was this xy part. And that's going to be y plus x dy dx. Plus, deriving 5xy, calls for the product rule. That's going to be 5y plus 5x dy dx. And simplifying this whole thing down, everything without a dy dx is going to be on top. And that's going to be this 5y. And this secant xy, tangent xy times y. Because we really have to distribute this guy into this y and the x dy dx. So the first part's going to be y times secant xy, tangent xy, and that's not going to have a dy dx on it. Like that. And then we're going to divide by everything that does have dy dx from the left-hand side. That's going to be negative 2y cosecant y squared cotangent y squared. We're going to have to subtract 5x dy dx off both sides to get them to the left side. So that's going to be negative 5x when you divide by it. And then we're also going to have negative x secant xy tangent xy. Okay. If you don't like this, again, you can simplify it all by yourself if you want. Move everything over, factor this all out, or expand it all out, and you're going to get the same answer. Okay. That was 8. Number 9. Find all horizontal tangent lines to the curve 3x squared plus 4y squared is 9. Now, when you see all horizontal tangent lines, what they're telling you is that they want the tangent lines to be horizontal. That's no big secret there, which means the tangent lines are going to have a slope of 0, and the slope of the tangent line is the same thing as dy dx. They're really asking you, find out where dy dx is 0 as the first part, and then create a line that has a slope of 0 through that point on this curve. So to find out where dy dx is 0, we got to derive this thing. So we're going to get 4x plus 8y dy dx equals 0, which means, not 4x, I'm sorry, 2 times 3 would be 6x. 6x plus 8y dy dx. So that's going to simplify down to negative 6x over 8y, which is going to be negative 3x over 4y. That's our derivative. And again, since we're looking for horizontal tangent lines, I say and again a lot, I know. We're looking for horizontal tangent lines, which means dy dx is 0. This is dy dx. Where does it equal 0? That is the first part of what we're looking for. Anytime you have a fraction equal to 0, all you really care about is the numerator equaling 0. You can think of that as equivalent as multiplying both sides by 4y. This is going to become 0 still. Negative 3x equals 0, which means x equals 0. So the tangent lines will be horizontal when x equals 0. So here's what we have. We're looking for tangent line with a slope of 0, and we need a point. Well, we know x is 0. We're looking for a y value. When you have an x value and you're looking for a y value, you always use the equation you were given, because there's only two variables, x and y. If you know x, you can find y. So we know x is 0. Let's find y. When x is 0, we have 3 times 0 plus 4y squared is 9. So 3 times 0 goes away. Y squared equals 9 over 4, which is the same thing as y is either positive or negative. Square root of that, which is just 3 over 2. Meaning when x is 0, there are 2 points there. One at 0, 3/2, one at 0, negative 3/2. So we're going to have 2 tangent lines that are horizontal. Because if x is 0, the tangent lines are horizontal. And there's 2 points where x is 0. No big deal. We got this. The first tangent line, you can think of it, remember, like this. Y minus the y value is equal to the slope times x minus the x value. And that just simplifies to y equals 3/2. You also know if the line's horizontal, it has to be y equals a number. And if the y value is 3/2 of 1 point, then it must be 3/2 everywhere. Same thing with the other tangent line. Y is negative 3/2. Okay, and this should not be much of a surprise, I'm hoping, because 3x squared plus 4y squared equals 9. If you remember this from pre-calc or algebra 2 or wherever you learned this, that's an ellipse. X squared and y squared, both positive, have different coefficients. That's an ellipse. And it's centered at 0. And if there's an ellipse centered at 0, you know it's horizontal at the very tippy top. And this is a poor drawing, but the very, very bitty bottom. I don't know how to say that. But it's centered at 0, 0, so the very top should be right above and right below that. And that's 0, 3/2, 0, negative 3/2. And those lines are right there. Okay. What else we got? Oh man, second derivative, no problem. If you want to find the second derivative, that's what d squared y over dx squared means. You got to find the first derivative, so derive both sides. 2x plus y plus x dy dx plus 2y dy dx equals 0. Now, you never want to derive this thing again if you haven't found the first derivative yet, if that makes any sense. Because then you got to do product rule with the y and everything. It's just going to be super, super weird and nasty. So let's solve for dy dx first, and then derive it again. It makes it much simpler for us. That's going to be negative 2x minus y over x plus 2y. Okay. Second derivative means derive both sides again. And really the notation for this d squared y comes from the fact that we're doing d dx of that whole thing again. So it's dd, which is d squared y, over dx times dx squared. So d squared y over dx squared. This would equal the derivative with respect to x of this guy, by the way. Okay, and to derive this thing inside of here, we need to do the quotient rule. Quotient rule says low d high, so the bottom times derivative of the top, negative 2 minus dy dx, minus the top, negative 2x minus y, times derivative of the bottom, which is 1 plus 2 dy dx. All of that's over that bottom squared. X plus 2y squared. Now you're done the calculus here. The hard part of this problem is really simplifying this whole nasty thing down. I'll start it. I'm probably not going to finish it. It's a lot of work and it's ugly, and I don't think you'll be required to do that in a calculus class. You might be if your teacher is a real stickler. What are we going to do here first? So this is x plus 2y. The first thing that you definitely want to do is do not leave dy dx in your answer. That's bad. Dy dx, remember, we already solved for dy dx. Let me get rid of these dx's. Dy dx equals this guy. So at least write that out. Negative 2 minus 2x minus y over, well, negative 2x minus y over x plus 2y. So that's our first part. You know the parentheses there. Minus, and this negative 2x, negative y, and this negative is just going to really become plus. Plus 2x plus y times 1 plus 2 times dy dx, which was negative 2x minus y over x plus 2y. And this is really getting out of hand. This is all divided by x plus 2y squared. Okay. This might simplify pretty nicely. X plus 2y is going to cancel with this denominator here, so that's going to leave this. And you can multiply it all out. It's really just a little bit of algebra. Well, a lot of algebra. I'm not going to do it. If your teacher makes you do it, I feel very, very bad for you. But yeah, and in my class, this would be fine for me because this you get the main point. You got the second derivative. I'm not worried about you simplifying it down past that. Okay, congratulations. Implicit differentiation practice 1, all done.